Hello everyone, welcome back to my channel Gems of Knowledge. So I am here with another video on the topic, is matter around us pure? Okay, so in today's video we are going to study about true solution and its properties. Then we are going to study about the colloidal solutions, suspensions and their properties. Okay, so before starting my video, make sure to subscribe to my channel and also click on the bell button to get the notification as soon as I post my new video. Okay, so let's start with the video here. So you can see here we are going to study about the true solution. So what is true solution? A true solution is a homogeneous mixture of two or more substances. Okay, so what is true solution? It is nothing but the homogeneous mixture. Okay, it is a homogeneous mixture of two or more substances. So what is homogeneous mixture? We have studied this already in our previous video. So those who are not aware of the what is homogeneous mixture, I'll provide you the link of that video into the description box. Do check it out. Okay, then a solution has a solvent and solute as its components. Okay, so let us now know what is the solute and what is the solute and solvent. Okay, so you can see here the component in the large amount is solvent. Okay, the component which is in the larger amount is nothing but the solvent, and the component in the lesser amount is nothing but the solute. So I'll give you the example for this. Okay, first we should know that what is solvent. The component which is in large amount is nothing but solvent, and the component which is in less amount is nothing but the solute. Okay, so example is given here, solution of salt in water. So when you make salt solution, what do? Is we take water in large quantity and we take salt in a smaller quantity. So this salt is nothing but the solute because it is in lesser amount, and the water is nothing but the solvent because it is in the larger amount. So I hope you have understood with the solute and solvent here. Okay, then example is given here, solution of sugar in water, iodine in water. So iodine, the mixture of or the solution of iodine into water is nothing but called as tincture iodine, then soda water, etc. So these are the examples for your true solutions. Okay, then we can have solid solutions. Okay, we can also have the solid solutions, they are called as alloys, and we can also have the gaseous solution which is called as air. Okay, air is nothing but the gaseous solution and alloy is nothing but the solid solution. So here the definition of the solvent and solute is been given. The component of solution which can dissolve the other component in it, this is solvent. I have given you the example here. Water is nothing but solvent here because it is a component, it is a solution that dissolve the other component into it. Okay, if we put sugar, salt, whatever we put into that water, it will be dissolved into that water. So it is nothing but called as solvent. And solute, the component of solution that is to be dissolved into the solvent, which we are dissolving into the solvent, it is called as solute. Okay, so let us see the properties of this true solutions. Okay, so the first point is it is a homogeneous mixture. So we have already studied this, okay, in the definition of the true solution, that it is a homogeneous mixture. Okay, then the particles of the solution are smaller than 1 nm. N is nothing but here nanometer. Nanometer is nothing but 10 to the power of minus 9 into meter. Okay, so the particles are so smaller than the 1 nanometer. It is again smaller than 10 to the power of minus 9 meter. Okay, in diameter. So the diameter of that particular solution's particles are lesser than this. Okay, so they cannot be seen by the naked eye. So we cannot see it through our naked eyes. Because of the small particle size, they do not scatter a beam of light passing through the solution. So because of the smaller size of these particles, the beam of light cannot be passed through this solution. Okay, so the path of light is not visible into the solution. You can see a picture popping up onto the screen. So here the beam of light is visible, whereas in this case there is no visibility of the particles. Okay. Then the solute particles cannot be separated from the mixture by the process of filtration. So here the solute particles cannot be separated by the help of the filtration. Then the solute particles do not settle down when it is left undisturbed. So we can say that the solution is stable. Okay. If we are leaving the solution undisturbed, without disturbing the solution, if we are leaving it, it is not going to settle down. So we can say that the particular solution will be stable. Okay. Then moving to the next part, that is colloidal solution. So colloidal solutions are nothing but heterogeneous mixtures of two or more substances. So in the pure solution, true solution, we have learned that it is homogeneous mixture, whereas this colloidal solution is nothing but the heterogeneous mixture of two or more substances. So here example you can see mixture of starch in water, mixture of egg albumin in water, milk, air containing dust and smoke, etc. So these are the examples for the colloidal solution because it is a heterogeneous mixture of two or more substances. Okay. Then according to this properties of this colloidal solution, we can say that it is a heterogeneous mixture, and here the particles cannot be seen by the naked eyes. Even here the particles cannot be seen. It cannot be separated by filtration. Okay. Then here also it was in the true solution also we cannot separate the particles with the help of filtration. Then particles do not settle down and the solution is stable. Okay. So particles cannot be settle down here also and there also the same case. Then a particle scattered a beam of light passing through it and the path of light is visible in the solution. Okay. So here only the difference is in these two cases, that is here it is heterogeneous mixture whereas the true solution is homogeneous mixture, and here in this case in colloidal solution sparticles will scattered a beam of light and it is also visible into the solution. But whereas in case of true solution, what happens is the beam of light is not scattering and it is not visible into the solution. Okay. Okay. Now we are going to study about the suspension. So what is suspension? It is a heterogeneous mixture of two or more substances. This is similar to the colloidal solution. It is also a heterogeneous mixture of two or more substances. So here example has been given. Solution of sand in water, solution of chalk powder in water, etc. So these are the examples for your suspension. So let us learn what are the properties of this suspension now. Okay, so here you can see the properties of suspension. Okay, it is a heterogeneous mixture and here the particles can be seen by the naked eyes. Okay, the particles can be seen because here example we have given sand in water. Obviously we can see the sand particles into the water, so it is directly we can say that the particles can be seen by the naked eyes. Then solute particles can be separated by filtration. Obviously when the sand is present into the water, we can separate it with the help of filtration. Okay. Then solute particles settle down and the solution is unstable. Again we can say the particles here will settle down and the solution will be always unstable. Then particles scattered a beam of light passing through it and the path of light is visible into the solution. Always the path of light will be visible into that solution. Okay. Okay, so here you can see the next thing what we have to learn is about the Tyndall effect. So what is this Tyndall effect? When a beam of light is passed through a colloidal solution, okay, the colloidal particles scatter the beam of light and the path of light becomes visible in the solution. So this effect is called as Tyndall effect. So this effect is obviously measured in the colloidal solution. It can be seen into the colloidal solution. So here what happens is the colloidal particles will scatter this beam of light and we can exactly see the the beam of light passing through the solution. So here you can see a picture popping up onto the screen where you can see exactly the Tyndall effect, how the beam of light can be seen into the solution. Okay, so this is nothing but called as Tyndall effect. So Tyndall effect can be seen when the light enters a room through a small hole due to the scattering of light by the dust and smoke particles. So you all know this phenomenon. Sometimes what happens is when a light is coming in from a small hole, so nearby that hole you can see the dust particles are moving into that particular light. So that is nothing but also we can call it as Tyndall effect. Okay, so Tyndall effect can be seen in a dense forest due to the scattering of light by water droplets in the mist. So about two situations, you can see the pictures popping up onto the screen of this about two situations. Okay, so this is where the light enters the room through a small hole and you can see the dust and smoke particles there, whereas the other one is nothing but the dense forest where you can see the scattering of light by water droplets in the mist. Okay, that is also an example for the Tyndall effect. Okay, next coming to the saturated and unsaturated solution. So we should know what is saturated solution as well as what is unsaturated solution. So first we will see what is saturated solution. A solution which cannot dissolve any more of the solute at the given temperature. So this is a saturated solution is a solution in which if we dissolve the salt, okay, whatever the solute we are going to dissolve, it will no more dissolve it. Okay, suppose if we are taking 5 grams of water and if we are trying to dissolve 10 gram of salt into it, so we can notice that few of the salt can be dissolved into this into that water and the other salt will be stuck inside that beaker as it is. It is not going to dissolve it. So that is what saturated solution means. The solution has reached at its saturated point. So no more solute into that solution is going to be dissolved. Okay, so that particular solution is called as saturated solution. Okay, so unsaturated solution, a solution which can dissolve some more of the solute at the given temperature. Okay, now suppose the same case, if you are taking 5 gram of water, okay, 5 gram of water, in that if you are trying to dissolve more than 5 gram of salt, it may take some time, it may take, if the temperature is increased, it may take. Okay, so that is what unsaturated solution, which can dissolve the solute is nothing but unsaturated solution and which cannot dissolve. Already it has reached at its point, that is known as saturated solution. Okay, then comes solubility. What is solubility? Amount of solute present in the saturated solution. So in the saturated solution, how much solute is present into that saturated solution, it will tell us the solubility of that particular solution. Okay, then preparation of a saturated solution. So here you can see how the saturated solution can be prepared. Take 50 ml of water. Okay, it has been taken, 50 ml of water is taken in 2 beakers. Okay, 2 beakers we have to take, and in that 2 beakers we have to take 50 ml of water each. Then add salt in 1 beaker with continuously stirring till no more salt dissolve into it. So we have to add the salt into that beaker and we have to continuously stir it until the salt is stopped to dissolve into it. Okay, similarly add sugar into another beaker and continue with the same process. In the next beaker we have to add with the sugar and we have to continue with the same process. We get saturated solution of salt and sugar. So here in both the cases we get the saturated solution of salt and sugar, because here what happens is at some point the salt is dissolving, salt is continuously dissolving. Both salt and sugar are continuously dissolving into this solutions. Okay, but at some point both the salt and sugar will stop dissolving into it. So at that temperature, at that point, we can say that we got a saturated solution of that particular liquid. Okay, so here you can see a note has been given. If the mixtures are heated, it dissolves some more of the solute. So we can say that if the mixtures have been heated, then it can dissolve some of the solute also. Okay, then the solubility of different substances are different. Obviously the solubility of different substances will be different. It is different for salt and it is different for sugar. Similarly, the solubility of substances varies with temperature. It also varies with temperature. If we give the temperature to that particular solution, it can dissolve some more of the liquid. Okay, then next coming to the concentration of the solution. So how can we find the concentration of that solution? It is the amount of solute present in a given amount of the solvent or solution. So how much solute, how much salt we are adding? So how much solute, how much salt we are adding into that particular solvent or solution will tell us the concentration of that particular solution. So here you can see a formula is been given here. Concentration of solution is equals to amount of solute divided by either it is amount of solvent or it is amount of solution. Okay, so here you can see the concentration of a solution can be expressed as mass by mass percentage or as mass by volume percentage. So we can calculate this either by mass percentage or mass by volume percentage. So here you can see mass by mass percentage. The formula to find mass by mass percentage is mass of the solute. First the mass of the solute we have to take and it is divided by mass of the solution multiplied by 100. Similarly, the formula for mass by volume percentage is mass by volume percentage of the solution is equals to mass of the solute divided by volume of the solute multiplied by 100. Okay, so these are nothing but the formulas to calculate exactly the concentration of solution or mass percentage of solution or volume percentage of the solution. So depending on this, here one problem has been given, exemplar. Okay, so you can see here a solution contains 40 gram of common salt. Okay, so one solution is containing 40 gram of our common salt in 320 grams of water. So actually the water is taken as 320 grams. Okay, and in that 40 grams of common salt is been dissolved. So what we have to do here, calculate the concentration in terms of mass by mass percentage of the solution. So we are up to here. Okay, so here we are up to calculate this mass by mass percentage of the solution. So we have to use this formula here. So directly we can write, already they have given common salt is 40 gram and water is 320 gram. So what is water here? It is nothing but the solvent and the common salt is nothing but the solute. So directly we can write mass of the solute, that is salt, is 40 grams and mass of the solvent, that is water, it is nothing but 320 grams. So by the formula we can write here, okay, mass of the solution. How to find out the mass of the solution? Now complete solution will be of both the things, solute as well as solvent. So if we add both the things, we will get the exact solution, mass of the solution. So mass of the solute plus mass of the solvent, if we add this, we are going to get 360 grams. Okay, then mass percentage of the solute. So directly we can write with the formula mass percentage of the solution is equals to mass of solute divided by mass of solution multiplied by, again it is 100. So mass of the solute, we know mass of the solute is nothing but 40 grams. 40 divided by mass of the solution is 360 multiplied by 100. So when we divide this and multiply it by 100, we are going to get 11.1 percentage. Okay, so depending on these above things, we are having the questions which are present on the page number 18 in your textbook. So here the first question is again the same question which I have provided you into the previous video, that is differentiate between homogeneous and heterogeneous mixture with an example. So I'll not provide the solution to this because I have already provided the solution for this in my previous video. If you are not aware of it, I'll link it into the description box. Do watch it. Okay. Then coming to the second question, how are salt, solution and suspension different from each other? So we have to make them understand what is salt, solution and suspension. We have to differentiate what is the things here. Okay. So first we will deal with the sol, then solution and then comes to suspension. So sol is nothing but the colloidal solutions. Colloidal solution are also called as sols. Similarly, solutions are nothing but the true solutions and suspensions. Okay. So the first difference here is it is heterogeneous, whereas this solution is homogeneous and suspension is again heterogeneous. Okay. Then second point is Tyndall effect can be seen. So here in the colloidal solution we can see the Tyndall effect, but here there is no Tyndall effect, whereas here we can see the Tyndall effect into the suspension. Then cannot be separated by ordinary filter paper. Colloidal solutions we cannot separate it by the ordinary filter paper. Then coming to solution, solute particles cannot be filtered by using a filter paper. Here also we cannot filter it by using a filter paper, but the suspension we can filter. See here, can be easily filtered, separated by using a filter paper. So suspension is a thing which can be easily separated by using the filter paper. Then it may be transparent or translucent. So the colloidal solution can be transparent or it can be translucent. Translucent in the sense slightly milky form, but we can see through it. Okay. So then coming to true solutions, it is true solution is transparent, clear, transparent like water. Then it may be transparent or translucent, similarly as this case. Okay. Then here examples have been given: fog, clouds, smoke, mud, etc. So all these are the examples for the colloidal solutions. Whereas for the true solutions they have given seawater, alloys, etc. So these are the example for true solutions, and mixture of sand in water or something other is the example for the suspension. Okay. I hope this answer is cleared. So next is a similar problem which I have shown you. Okay, so here the question is, to make a saturated solution, 36 gram of sodium chloride is dissolved in 100 gram of water. So already they have given 100 gram of water. So this is nothing but the solvent, and 36 gram of sodium chloride is nothing but salt again, that is 36 gram, it is nothing but the solute. So at 293 Kelvin, find its concentration at this temperature. Here we have to find the concentration. Okay, so directly we can write what is given. Mass of the solute is given, that is 36 gram, and mass of the solvent is given, which is 100 gram. So if we need what is the mass of the solution, we need to add both the things. We will get it 136 grams. If we add both the things, we are getting 136 grams. Then we need to find concentration, or we can say mass percentage of the solution. Both are similar. So what is the formula here? Mass of the solute divided by mass of the solution multiplied by 100. So 36 gram divided by 136 gram, which is multiplied by 100, is equals to, we are going to get 26.47. Okay, so percentage, this is nothing but the mass percentage of the solution. So I hope the video is cleared here. If you are having any doubts regarding this, you can comment me down below. I'll be back with another video. So till then, stay tuned and stay connected. Thank you.